Welcome to The Explainer. We've all been told that two-factor authentication is the digital deadbolt for our online lives. But today, we're going to show you exactly how a hacker can pick that lock, sometimes with a surprisingly simple trick.
So to really see how this all works, let's walk through a story. It's got a small online store, a really proud owner, and an ethical hacker who's about to prove that even the strongest fortress can have a weak spot.
Okay, so this is Sally. She's poured everything into her new online art store. And to keep her customers safe, she installed what she believes is just rock-solid security, two-factor authentication. In her mind, her store is a fortress. But a tiny, tiny oversight has left a door unlocked for someone like Kim.
And here's Kim. Now, he's not a criminal. He's what you call a penetration tester, an ethical hacker. He's been hired to find these security flaws. He's already found a different vulnerability, a little crack in the website's code, and through that, he's managed to grab a bunch of user passwords, including one for a customer named Jane.
All right, so Kim takes Jane's password and he goes to log in. He gets past that first gate, no problem. But then, bam, he hits a second wall. The site is demanding a 6-digit code from Jane's phone, which, Kim obviously doesn't have.
So it really seems like he's stuck, right? Is this the end of the road for him? Well, not quite. And to understand how Kim gets past this, we really need to look under the hood of how this whole security system actually works. Let's just quickly pull back the curtain on the tech that generates those magical little 6-digit codes that pop up on your phone. At its core, two-factor authentication is really simple. It just needs two things to prove you're you. First, something you know, your password. And second, something you have, like that temporary code from your phone. Think of it like having two totally different locks on your front door. So how does the code get made? Well, it uses this open standard algorithm called TOTP, which stands for time-based one-time password. It all starts with a secret key that's shared between your phone and the website's server. The algorithm takes that key, mixes it with the current time, and boom, a new 6-digit code pops up every 30 seconds. So here's the absolute crucial point. This whole system, all of this security, it all hinges on keeping that one shared secret key completely private. See, Kim doesn't need to steal Jane's physical phone. He just needs to find her secret key. Okay, so how on earth does he find it? Kim knows that key has to be stored somewhere on Sally's server. And since he already found that crack in her website's database, well, that's exactly where he's going to start hunting. Kim goes right back to that database vulnerability. He uses a technique called an SQL injection, which basically lets him talk directly to the database. He's betting the secret key is stored right there with all the user passwords, but he doesn't know what the column is called, so he's got to guess. He changes his command and tries his first guess, TOTP key. The server just kicks back an error. No such column. Okay. He tries again, this time with TOTP key, all lowercase. Same thing, another dead end. But Kim is persistent. He pauses for a second and thinks, what would a developer actually name this? He tries a more descriptive guess. His third try is top secret. He sends the request. Bango, no error this time. The server responds with 200 OK, and there it is, sitting right next to Jane's user info. A long string of letters and numbers. That's her secret key. And for the website's defense, it's pretty much game over. So now that Kim has the master key, that secret ingredient, he can do something pretty incredible. He can create a perfect digital copy of Jane's authenticator right there on his own device. And the process is, well, it's shockingly easy. He just opens his own Google Authenticator app, taps to add a new account, but instead of scanning a QR code, he chooses to enter a key manually. Then he just pastes in that secret key he stole from the database. The second he hits add, his phone becomes a digital clone. It starts generating the exact same 6-digit codes that are showing up on Jane's phone at the exact same time, all perfectly synchronized. He has totally bypassed the need for her physical device. So now, Kim just heads back to the login screen. He puts in Jane's password, that's the something she knows. And for the second factor, he just glances at his own phone and types in the code it's showing him. He has both pieces of the puzzle. And just like that, he's in. Access granted. He's got full control. He can see her entire order history, change her address, even make new purchases. And you know the scariest part? To Sally's system, everything looks completely legitimate. No alarms go off, no warnings, nothing. So how did this even happen? I mean, how did a system that's designed to be so secure fail so completely? And what's the big lesson here for all of us?
The answer really comes down to a simple truth. Sally used two-factor authentication, and that is a very strong lock. But the weak link here wasn't the lock itself. It was the fact that she was storing the keys, the secret keys, insecurely, just sitting there in the database in plain text. And this is why every single layer of your security matters. It means you have to use strong password hashing to scramble passwords, you have to actively prevent attacks like SQL injection, and most importantly, you should never, ever store sensitive data like these TOTP secrets as plain text. They should always be encrypted.
So does all this mean you should just stop using 2FA? No, absolutely not. What it means is that 2FA is an incredibly powerful piece of a much larger security system. It's not some magic shield that makes all the other security practices optional. Real security means protecting every single link in the chain. If this explainer helped you see how security really works behind the scenes, make sure to subscribe to Refreshing Tech. We've got a lot more simple and useful tech insights just like this one.